Evaluate L of integral 0 to t e power minus 2t t sin 3t. Here in the problem we have multiple principles. We have to apply more than one principle. One is multiplication by t principle, first shifting theorem, Laplace transform of integral. So this is nothing, Laplace transform of integral. Laplace transform of integral is nothing. Simply you need to write 1 by s before Laplace formula. So this is about the integral principle. We call this one as Laplace transform of integral. This is about integral. You know about first shifting theorem. L of e power minus at f of t. If you have, simply find out Laplace for f of t. In that, write in the place of s plus a. Next principle, multiplication by t. L of t f of t equal to minus d by ds L of f of t. So these three principles we are going to apply here. So you know, this is Laplace transform of integral. Laplace transform of integral. This is first shifting theorem. First shifting theorem. This is multiplication by t. So three principles we need to apply here. This is nothing. For integral we are going to keep 1 by s. If you have double integral we are going to keep 1 by s square. First shifting theorem, simply replacing s with s plus a. Next, multiplication by t only we need to do now. This is differentiating Laplace formula. That is, whenever we have first shifting theorem along with some other principle, what I am saying, first prepare that principle other than first shifting theorem. Apply first shifting theorem at the end. First shifting theorem, multiplication by t. Then first apply multiplication by t. Next apply first shifting theorem. So because first shifting theorem is easy, simply replacing s with s plus a or s with s minus a. But in the case of multiplication by t, you have to differentiate Laplace formula. That's why what I am saying, first shifting theorem, multiplication by t, or first shifting theorem or division by t. If you have in product, if you want to apply the two principles, prefer first shifting theorem at the end. So what I am saying, now first apply multiplication by t. L of t sin 3t. So if you have t in product, you need to differentiate Laplace of sin 3t. What is Laplace transform of sin at? You know that. L of sin at. L of sin at equal to a by s square plus a square. Minus d by ds 3 by s square plus 3 square. You can keep 3 as common. So minus 3 into d by ds of 1 by s square plus 9. Use this formula. Differentiation of 1 by x. We know this, minus 1 by x square, and also differentiation of x square to x. We know these two formulas, differentiation formulas. Using the two differentiation formulas, minus 3 into, treat this one as x. Differentiation of 1 by x, minus 1 by x square. Again differentiate s square to s. Minus into minus plus, 3 2s are 6. 6s by s square plus 9 whole square. Now, multiplication by t principle is over. Multiplication by t is over. Now, we need to apply first shifting theorem. So that is this one. L of e power minus 2t into t sin 3t. That means in L of t sin 3t, replace s by s plus 2. Write in the place of s plus 2 because you are having minus 2 here. So L of t sin 3t, you know what you get. Just now you get L of t sin 3t value 6s by s square plus 9 whole square. In this replace s by s plus 2. Write in the place of s plus 2. So here like this. This is 6s by s square plus 9 whole square. In this replace s with s plus 2. What you will get? 6 into s plus 2 by s plus 2 whole square plus 9 whole square. So that simplification of our wish. If you want, you can keep like that. L of final one, integral 0 to t, e power minus 2t, t sin 3t dt equal to. What I said, simply keep 1 by s before the remaining term evaluation. This one. 1 by s into L of e power minus 2t, t sin 3t. This value you know. L of e power minus 2t, t sin 3t value. So in that write 1 by s before that term. 6 into s plus 2 by s plus 2 whole square plus 9 whole square. If you want, you can expand this one using a plus b whole square. You can expand this one using a plus b whole square, you can end the problem. So like this, we can evaluate Laplace transform of a function in which we are having more than one principle, like multiplication by t, first shifting theorem, and Laplace transform of integral. Okay.